Brooke, these are not my slides. We have my slides? Do we have my slides? Can you hear me? We're going to have a little chaos before we get started, just to make sure you're on your toes, make things a little more lively.
Are they coming, guys?
It's the afternoon. We gotta get up out of our seats. Maybe, maybe not. Okay. All right. Thank you very much, Brooke. Good afternoon, everyone, and thanks for the opportunity to be here. As a founder, as Brooke was saying earlier, being a founder and going through this journey can be difficult at times. One of the things that I'm very grateful for is some good advice and some good mentors along the way. So hopefully you'll find this to be useful, and if not, I'm happy to help you out in your journey or provide some advice to you. I cut my teeth at Amazon on this concept called chaos engineering. Didn't really have a name at the time. It was just failure testing that we were doing. I was part of the team responsible for ensuring that Amazon.com always worked, that people were always able to purchase things, and that it worked correctly. And when Amazon breaks and we have downtime, it costs tens of thousands to hundreds of thousands of dollars a minute. So it was well worth the time and investment to prevent those outages and that downtime. We began doing fundamentally reactive things, similar to what many of the DevOps and SRE movement is about now. Better engagement, incident management, good postmortems. But one of the things we learned is in order to reach our high goals of availability, we needed to do something different. And what we found, which was a bit surprising, is that we needed to go out and we needed to break things on purpose in our systems before they cause major incidents. We use this to find and fix the types of things that went wrong. Now, some of you may have heard of Chaos Monkey from Netflix. And after my time at Amazon, I had the privilege of going and working at Netflix. And what I found was the same thing held true there. We really needed to reach our high goals of reliability. We really needed to go out and we needed to test things before they went wrong. So chaos engineering is the practice of thoughtful, planned experiments designed to reveal the weakness in our systems. This might sound a little bit counterintuitive, and so I like to explain it with a bit of an analogy. I think of the flu shot or the vaccine. Now, if we went back 200 years and we said, hey, I'm going to inject you with this disease, is that cool? You might have got mixed results. But we know now that there's a lot of credence to this approach, this concept of hormesis. This same thing applies in the systems that we build. By going in and injecting small amounts of harm in a careful and precise manner, we're able to uncover weaknesses before they result in customer-facing outages. Furthermore, this helps us train our teams and helps our immune system, so to speak, to get into gear and to be in a position of protecting us. It's important to be able to test this not just technically, but socially. Many of the important parts of a complex system running smoothly involve the people that operate it, and the opportunity to train those people, the opportunity to prepare. Think of it like a fire drill. When things go wrong and it's an emergency situation, we don't want everyone panicking and we don't want everyone rushing about quickly. We want people to have prepared for that, to have had an opportunity to think through it. And that helps us to train, to keep calm in the moment of panic. It also gives us an opportunity to ask questions about our services, about our systems, about our processes. If the only time we get to practice this is 2 in the morning when everything's on fire and it's an urgent rush to fix it, we don't have that opportunity to train and to test. Imagine instead a world where with our engineers and the people that operate these complex and crucial systems, we're able to go in and we're able to have a game day, to have an exercise where we can practice these things. We can see how the system fails. We can test that our monitoring works correctly, that we're alerted as we should. People that are new to the team or haven't operated it before have an opportunity to ask questions, to better understand what should happen and how they need to react. This is a crucial part for us that we discovered at both companies. In order to get past this hump of the 3 nines, 3.5 nines of availability world and get to 4 nines or better, we really needed to apply this approach to prevent things from occurring. So I wanted to pick a couple of examples from the press of recent outages. Amazon had a rough Prime Day this year. It's a bit akin to Black Friday, a very high revenue generating day. They were down for an hour and a half. It was estimated to cost them tens to hundreds of millions of dollars in lost revenue. I believe the per minute cost was $200,000. That's a huge amount of revenue lost. But then what's the impact to your brand, to your customer trust? How many engineers at Amazon that day were running around trying to fix things for hours on end? And that's just the tip of the iceberg. As someone who's lived that world, as someone who's been on call and carried that pager, I know that those teams spent days afterwards understanding what went wrong and how to prevent it from occurring again. Again, with chaos engineering, we do that preparation in advance of the incident. We find the things that could go wrong before they break. It gives us that opportunity to test and to train. We're a remote by default company, and we rely pretty heavily on Slack for communication and collaborating across our company. There's been a couple of rough spots this year where Slack has been unavailable, and this has left our team unable to communicate, unable to collaborate. This isn't unique to us. Many people throughout the industry feel this pain when this occurs. So this is a key aspect to how we do work, and we want to ensure that it happens smoothly. Lastly, we've had a couple of major airline outages in the past year. Delta comes to mind, but we've also, there was a big British Airways one early this year, late last year. Both of these were estimated to cost $100 million plus. The important aspect here is not necessarily the money lost, but the impact to us as customers and as a society. We rely on the ability to travel, to see our loved ones, to get business done, to be able to make it on time to things. And when these critical systems break, it becomes more than a major inconvenience to us. It can have an impact on our businesses or on our lives. And as we continue to move into a world where we are increasingly reliant on the internet and its services for finance, for healthcare, for transportation, these systems are only going to become more and more mission critical. The ability to ensure that they work when we need them to is of the utmost importance. It's not always the most interesting or compelling approach to go in and handle the operation of a system, but it's critically important. So how do we do this? At Gremlin, we like the idea of a game day, an opportunity to practice these types of failures. We're not ad hocly going out and just randomly breaking things. We're applying the diligence of engineering. We're taking the scientific method and we're applying it to how we learn about our systems. We have some hypothesis. How will our system behave if our database fails? What happens if our cloud provider has an outage? What happens if all of the data we store in S3 or some other service becomes latent and it takes us much longer to access it? What is the impact to our customers, and how are we able to measure that? From this, we're able to derive the experiment we want to run. Now, a key part of this is the goal of these incidents, the goal of these game days is to prevent customer pain. So we don't want to go out and cause customer pain to prevent it. So what we do is we apply this concept of the blast radius. When we run an experiment, we want to run the smallest experiment that will teach us something. We might want to impact a single user or a few devices. We might break only a couple of servers. And from that, we'll find one of two things. Either our assertions won't be met. The system will not behave in the way we expect. Great, that's what we're here for. We found some bug, some problem that may have resulted in a major outage down the road. We're able to take that offline and we're able to fix it. Or our assumptions hold. The system gracefully degrades. Systems behave the way we want them to. In that case, we can scale it up and we can run it across many servers or many regions or many zones until we're running it at 100% in a live environment. And it is crucial to run in a live environment at the end of the day. Production is where our customers live. Production is where our money is made. Production is unique and never the same as staging. And so there's always a class of things that we need to test in production to be able to find. But this approach allows us to mitigate the risk and do it in a much more thoughtful and safe way. So this is what Gremlin is about. We built this tooling, and we helped pioneer this approach at Amazon and Netflix. And we've taken what we've learned from the past 10 years and our work at those companies to build it into a platform that enables people to safely, securely, and simply run these chaos experiments. We have a few customers you've probably heard of: Twilio, Walmart, Under Armour, a few financial industries. This cost of downtime is very apparent in e-commerce, in finance, in SaaS, and so it's well worth the investment to help prevent and protect against these types of issues. At Gremlin, our mission is to help build a more resilient internet. We care deeply about the internet's value to us as a society, and our team, having done this for many years, cares about building this in a way that works well and helps protect customers. So with that, I'd invite anyone who is looking to be a founder to come find me. I'd love to give you my thoughts or help you along your journey, and I thank you very much for your time.